Hello everyone. Today I will be presenting my research project titled Solar CCTV for Sustainable Oil Palm Management, a Smart Burn Oil Monitoring System. My name is Muhammad Danish Aiman bin Najmi YD, and this project focuses on integrating IoT and solar technology to improve conservation effort in agriculture sector. In oil palm plantation, the barn owl is a vital partner. They serve as a natural biological control agent for managing rat population, which is a key part of sustainable pest management. For this strategy to work effectively, we must monitor their occupancy and breeding performance in nest box over the long term. Currently, monitoring these nest bots is done through manual inspection. This process is not only time consuming and labor intensive, but it also risks disturbing the owls and creates safety hazard for worker. Additionally, maintaining power for electronic monitoring in the shaded condition of a plantation is a significant challenge. The primary objective of this project was to develop an autonomous system using the ESP32 CAM. We focus on implementing a scheduled wake sleep operation to minimize energy consumption while providing reliable real-time visual data without human disturbance. For the methodology, the technical setup include a 6-volt solar panel connected to a CN3791 solar charger to ensure sustainable power. The ESP32 cam is the core component capable of capturing visual from inside the nest box. As you can see from the prototype, the system is designed to be compact and easily mounted. To manage the system remotely, I use the Blink IoT app. This allows me to wirelessly set monitoring schedules, toggle the flashlight, and synchronize the camera's active hours via RTC memory. The visual stream can be viewed directly through a web browser using the IP address provided by the ESP32 cam. Our first major result was successful remote schedule synchronization. We were able to update monitoring schedules wirelessly via Blink, and the system maintained a reliable wake-sleep operation using RTC memory, which is crucial for preserving battery life. So, to test the result one, which is the wake up sleep, first we open the Blink app, which I already set up, and we set the time for wake up and sleep operation. For the setting, I choose 6:59 p.m. for sleep and wake up on 7 p.m. To test the sleep and wake up function, I just turn on the flash LED button to see whether it's still wake up or sleep. Now on my phone, it shows 6:59 p.m. which should be in sleep mode. Since I don't switch on the timer, the LED will keep flashing on. By tapping the timer switch, the LED should turn off because right now it is 6:59 p.m. The camera will wake up on 7 p.m. So now we just have to wait until 7 p.m. Or you guys can just skip it to the 7 p.m. to see the result. Now the time shows 7 p.m. The camera will receive the signal to wake up, meaning during this short time, even tapping the flash button, it will not flashing the light since the camera will receive a sudden high voltage to turn it on. As you can see, the device is now connected, and when I turn on the flashlight, it will work. So here on the website with the IP address provide the camera, we can test whether the camera work perfectly. As you can see, it shows clearly image of myself. That's all. For the second result, which is real-time visual data, we achieve successful non-intrusive real-time visual data capture. It can be monitored without ever opening dashboards or disturbing the local wildlife. So to test it, I put the camera inside the barn hole, and then I put the battery, then check whether to see whether it's go online, and you can see the device is connected. And now we start the stream, and you can see the inside barn hole. Then I put my hand inside the barn hole and move my hand to check the stream show it clearly. Then we test the flash button, check it worked perfectly. And on the stream, flash button can be clearly seen on the stream too, and it should be good enough. In conclusion, the smart barn owl monitoring system offer a practical and sustainable solution for modern plantation. By reducing labor and minimizing wildlife disturbance, this technology supports sustainable management and enhance the effectiveness of natural pest control strategy. That's all from me. Thank you for listening.